Hello students, how are you all? It is nice to again meet you through this video lesson. Today we'll be starting with the numerical problems of work, energy and power. So turn to your book in page number 350 and we'll be doing the example questions. So the first example question which is given here, the sign of work done is given here, whether it is positive, negative or zero. So this is a very simple question, you can do it yourself. We'll go to question number 2. So please read this one carefully and try to understand the question, and we'll try to do this one. So the question says, a body constrained to move along z-axis. So the direction in which it is going, it is moving on, it is z-axis of the coordinate system, is subjected to a constant force. The force is given here. So this is the force which is given here, and I cap, j cap and k cap are the unit vectors. So these are the x-axis. What is the work done by this force in moving the body of a distance of 4 meters along z-axis? So it is saying 4 meters along z-axis. That means 4 meters along z-axis, and what does it mean by that? The distance is going to be equal to 4, which direction? Z-axis. It is going to be k cap. 4 k cap is the distance here, and here 3 meters along y-axis. So distance is going to be equal to which one? 3 j cap. So we need to find out the work done here. Quite simple. So what is the work done? Work done is going to be equal to force into distance. So force you have to put here, dot product of distance you need to put here. Force is going to be equal to minus I cap plus 2 j cap plus 3 k cap, and this is 4 k cap. So this is the first part of the question. So we know already the value is, whenever you have a I cap into I cap only it should be there, j cap into j cap and k cap into k cap only you can do, because it is a dot product. We have seen this one earlier itself, we have done quite a lot of questions, so I'm not going to repeat that. So it becomes 3, because this one, into 4. So that's what it is, 12 joules. Now tell me what direction it will be. It will be k cap? No. Remember, work done is a scalar quantity, dot product. So answer will be a scalar quantity. Second part, W is going to be equal to F dot S is going to be equal to I cap plus 2 j cap plus 3 k cap into 3 j cap. So this one and this one only will get multiplied, because you need to do the work done. 2 into 3 is going to be 6 joules, right? The question is not over. What is the total work done? So the first work done is 12 joules, next work done is 6 joules. Now this was from the direction of z-axis, this was from the direction of y-axis. Now tell me, what is the total work done? How will you find out the total work done? Total work done. So some of you will say, sir, this is k axis and this is j axis here and this is a k axis here. So k cap and j cap, and then we need to take this one. Please don't consider all these things. Work done is a scalar quantity. So 12 joules plus 6 joules is going to be equal to 18 joules. No direction, no resolutions, nothing. You just need to add here. Okay, we'll go to the next question now. Turn to the next page, page number 351. So this is a pretty a long question which has a simple thing, but it is need to be a little more understood clearly. A raindrop of radius 2 millimeters. So radius is going to be equal to 2 millimeters. A raindrop means it is going to be a spherical shape. From a height of 500 meters above the ground, it falls decreasing acceleration due to the viscous resistance of the air. So the raindrop, when it falls down, because of the viscous resistance of the air resistance, it is actually coming down with the, not with a greater velocity, change in velocity, but it is going to be a decreasing velocity. So that means the decreasing acceleration also it's going to be there until half the height. So until the height of half the height means 250 meters. It is coming decreased. It attains a maximum terminal speed and moves with uniform speed thereafter. That means after this one, the raindrop is coming down till the ground for the next 250 meters with a same velocity. This velocity is called terminal velocity. It is not in increasing the velocity, because every time whenever the drop comes down, the velocity will be highly increased and it drops with the greatest velocity. But here it is stopped having any more increase in velocity. Now the velocity is now same, similar, it is coming down. So it is asking what is the work done by the gravitational force on the drop in the first and the second half of the journey. So it is asked here work done by the gravitational force. There are two parts, first half and second half. Okay, now you know already work done. Work done is going to be equal to force into distance. What is the force it is there? It is going to be equal to mg is the force and the distance is height. So height is going to be 250 meters. So mass into 9.8 into 250 meters, it is the distance which is there. But remember, where is mass is given? It is just given radius of this one only. We need to find out the mass of this particular thing. How to find the mass? So the first thing is, you need to understand mass of water drop is going to be equal to volume into density. So volume is going to be equal to, what is the volume? It is a spherical volume, spherical shape. It is going to be equal to 4 by 3 pi r cube into the density is going to be equal to 1000. 1000 is the value here. So 4 by 3 into 3.14 into, that is 2 millimeter, 2 into 10 to the power of minus 3 and the whole cube into 1000. So that is going to be the mass. Mass itself has come such a huge one now. Now you need to apply the entire thing over here and then you will get the work done. Right? So this will become 3.35 into 10 to the power of minus 5 kilograms. Only one drop. So put this value over here. So what is the work done now? 3.35 into 10 to the power of minus 5 into 9.8 into 250. So once you do all this calculation, you will get the work done. Right? The work done is going to be 0.082 joules. So that's the value of work done. You have to just calculate and do it. Okay. Now this is only one half of this one. 250 meters only we have put. 250 only is put. From here to here the work done is this much. Now tell me what will be the work done from here to here. Somebody will say, sir, only velocity is not changing, same velocity. So 9.8 what will become now? It will become 0. That's a big question. Always it happens. Many of them they will miss it very much profoundly, because you will think this is a gravity here. Okay, 9.8 has come. Now what happens to here? It is velocity is same, so it's going to be same 9.8. Now listen here, same 9.8 will be here also. The acceleration will be same, but because the resistive force is equal, the velocity will still remain same in spite of the 9.8. So when the second half is there, okay, second half of height, second of the height, it becomes, so what is the value of V? So what is the value of V? V is going to be equal to 0, but G is going to be equal to, V is not 0, it's a constant. You can say it's a constant value. That's called terminal velocity. G is equal to 9.8 itself, meter per second square. So you get here, work done is going to be equal to M into G into height. Same thing. So you get the same value, 3.35 into 10 to the power of minus 5 into 9.8 into 250. So what is the value here? 0.082 joules will be the same value. Now what is asked here? So you have to find out first and second half will be the same. What is the work done by the resistive force? What is the work done by the resistive force? You need to find it out. So for the resistive force, how to do is, so it is going to be total work done. Total work done is going to be equal to change in kinetic energy minus resistive force. Change in kinetic energy minus resistive force. Or otherwise, I would also just give you the clarity of this one. What is the work energy theorem? Work energy theorem. It says change in kinetic energy is equal to total work done. So here total work done is going to be equal to total work done plus resistive force. Resistive force due to the work done due to resistive force. Alright. So you need to have that clarity. Change in kinetic energy is going to be equal to total work done. That's what work energy theorem says. Now what we need to find out here is, we need to find out the resistive force. So find out the resistive force because of this. So work done due to resistive force is going to be equal to total work done minus change in kinetic energy. So this is the basic thing we are going to base upon. So we'll try to do one by one. Okay, we are still on the second part of the question, right? So total work done is going to be equal to, we already knew this one was coming from, this is first work done, second work done. What is the total work done? We already know was the value of the first work done, this was the value of the second work done. Add both of this one. So you can, total work done is going to be equal to 2 into 0.082. So what will be the value then? 0.164 joules. That's a total work done. Next one is change in kinetic energy is going to be equal to final KE minus initial KE. So final KE is half mv square minus initial KE is 0. So we need to find out what is a half mv square. Mass is already, we know this one. It is 3.35 into 10 to the power of minus 5 of the drop. What is the velocity? The velocity is given here in the book itself. Reaching the ground in 10 meter per second. So velocity is 10 meter per second. So it makes it as v square is 10 square. So the change in kinetic energy called delta K you will get. So once you do this calculation, what you will get is this one, it will get cancelled out. Okay, you will get 1 point, this one will be 6 and then 75, 1.675 into, so this whole thing you will get it as 1.675 into 10 to the power of minus 3 joules. So now look at this one, very simple now. Total work done this much, this one is done, subtract both this one, you will get a resistive force. So moving further, so you get here work done due to resistive force is going to be equal to work done minus delta K, 0.164 minus 1.675 into 10 to the power of minus 3, right? 0.164 minus, this will become 0.0001675. So no, 0.00 here it's 1675. Okay, because you're just pulling this one and then two other zeros. Okay, I'll again repeat 0.001675. that will be the value. So you subtract these two. When you subtract this one, it will almost come the same only. 0.162 will be there, right? So this is work done in resistive force. 162 something will be there. In fact, there is a small mistake. I think it has been done. Work done. It is not work done minus this one. It should be delta K minus work done. So that should be the actual thing. It is going to be 0.01675 minus 0.164. So it will be actually, the value will be minus 0.162 joules will be there. Okay, there's a work done in resistive force. Alright, so it looks to be very broad, a big question, but has a very important concept. There is a resistive force. It also does the work done. So last part, I will just quickly explain again what we finally found out. This was coming down, there was a constant resistive force, and because of that the velocity became exactly the constant velocity. It just came and it was dropping down at 10 meter per second. That means from here to here it just came in the same speed of 10 meter per second. Now the stop velocity was 0 and finally it came at 10 meter per second. So the change in kinetic energy we need to find out. So already there was a mgh, there is a work done which was there because of the height here. mgh was there, work done, and then there was a change in kinetic energy. When you subtract, you will get the resistive force, the work done due to the resistive force you will find out. So that is what it was asked. What is the work done because of this one? So we found out 3 work done were there. One is the work done due to the gravity force. Next one is because of the gravity force there is a change in kinetic energy, and then there is another value of work done due to the resistive force. Alright, seems to be a long question, but it has a lot of significance. Let us go to the next question now. So this one says a pump on the ground of a building can pump up water to fill a tank of volume 30 meter cube. A pump can do that much of work and the time taken is 15 minutes. If the tank is 40 meters above, height is going to be equal to 40 meters. And the efficiency of the pump is 30 percentage. So it is efficiency equal to 30 percentage. How much electrical power it is consumed by the pump? Power is going to be equal to question mark. So take, these are the constant. G is going to be equal to 9.8 meter per second square, and then rho, the density of water, is going to be equal to 10 to the power of 3 kg per meter cube. Right? So the first thing is you need to find out the value of, this is the tank and it is above the ground. Above the ground it is going to be 40 meters, and from here when it is going, within 15 minutes it is just filling it up. Now we need to find out the mgh here. Okay, potential energy is going to be equal to m into g into h. So what is mass? Mass is going to be equal to volume into density. So it is going to be equal to volume into density into g into h. So what is volume? 30. What is the density? 10 to the power of 3. What is the one? 9.8. What is the height? 40. So that is the potential energy which is there. That is much is the energy which is required. So that much energy you will be supplying over there. Answer will be 117.6 into 10 to the power of 5 joules. That is the potential energy. Now it is asked here, when you are giving this much of strength, energy to take it up, 30% is the efficiency of the pump. That means 70% will be wasted. It will waste 70% of the energy. Only 30% of the energy which is there, it will go up. So what does that mean? So if it is stored as potential energy here, remember it is coming under huge cost. This is only 30% of the energy which is being given. 70% of the energy is already lost. due to various process. Now you are asked to find out how much is the power which is being given here. The total energy which is given to this one, it should be this one plus the 70% of this one which has been lost. You need to compare and add both together. That is the total energy given by the pump. So then only you can find out the power of this one. We can also do one thing. We can find out the output power. Output power is the rate of doing this work, potential energy upon time taken. So we know 1176.6 into 10 to the power of 5 upon 15 minutes. What is that is equal to? 117.6 into 10 to the power of 5 upon 15 into 60. That will be the power output, right? So what is the power output if you try to calculate? If you calculate, it will be 13.1 into 10 to the power of 3 watts. In other words, it is 13.1 kilowatt you can write. That's a power output. Now power input we need to find out. Power input, it is question mark. Efficiency is 30%. How to find out efficiency in 30% and how to do this one? Efficiency formula is simple. It is a very simple formula. Efficiency is going to be equal to power output upon power input. Output upon input. Anything output upon input is equal to efficiency. 30% is going to be equal to 13.1 into 10 to the power of 3 upon power input. What is the power input? You need to find out. Power input is going to be equal to 13.1 into 10 to the power of 3 divided by, so this one is going to be equal to 0.3. So 0.3 it will come here. So power input is going to be equal to that much, you will get the answer. It is 43.6 into 10 to the power of 3 watts. It is 43.6 kilowatts. That is the power input. Okay. So the efficiency is quite important, that they will have a kind of an idea. You will get 30% only the efficiency is there. So the value is going to be, the input is going to be so much. This much input power you gave and output how much you got? Only 13.1 only you get because of the 30% efficiency. Okay. Fine. We'll go to the next question now. Yeah, question number 5. A body of mass 0.5 kg travels in a straight line with a velocity. Now it's given here as velocity v is going to be equal to, so v is a x to the power of 3 by 2, where a is going to be equal to 5 meter minus half second minus 1. That's what it's given here. A is going to be this much, right? What is the work done by the net force during the displacement? X is going to be equal to 0 and x is going to be equal to 2 meters. The first thing that we got to do is find out the velocity v. V is going to be equal to, a is 5, put this 5 here, 5 into x to 3 by 2, right? So it is multiplication, or otherwise you can just put a bracket also, 5 into this much. When x is equal to 0, what will happen? V1 is going to be equal to 5 into 0, 0. When x is going to be equal to 2 meter, V2 is going to be equal to 5 into 2 to the power of 3 by 2. And you will get an answer. How to do 3 by 2? It is easy. 5 into 2 cube into 2 to the power of half. So 2 cube is 8. 5 into 8 into under root 2. What is that? 1.414. 1.414. You multiply, you will get the answer V2. Right? I think this is a wrong concept. I don't think this is the way it will work. Now look at this one. I'll once again explain this one. This will not the way. I'll just explain again. V2 is going to be equal to 5 into 2 into 2 to the power of 1 into 2 to the power of half. When you try to do the addition of this one plus half, it's going to be equal to 3 by 2. So it's going to be equal to 5 into 2 is 10 into this one is 1.414. So it's, in other words, it's going to be equal to 14.14. So you will get 14.14 meter per second. That is V2. Right, V1 is 0, V2 is this one, and then we need to find out the change in kinetic energy. So what is the question here? The question is, what is the work done by the net force? Work done by the net force you need to find out. That is change in kinetic energy. So work energy theorem says change in kinetic energy is going to be equal to work done by net force. Work done by the net force only is asked. So half m V2 square minus half m V1 square is equal to work done. This is 0. What is this one? 14.14. Okay, so what is the work done here? It is not 14.14. 14.14 is just a value here, right? It is going to be half into mass into 14.14 the whole square. So work done is going to be equal to half. What is the mass here? Mass is value is 0.5. It is going to be equal to 0.5 into 14. It is 10 under root 2 was there. The whole square will put, because it is going to be 10 under root 2. That's the way it is. Okay, so I'll just put this way itself. So this is going to be equal to 1 by 2 into 200. This is 200 because 10 square is 100. 200 into 0.5. So it's going to be equal to 50 joules. Work done is going to be equal to 50 joules. That's the answer. So looks quite big and complex question, but actually it's just a velocity. You will find out after velocity you need to find out the v1, the velocity is 0, v2, the velocity is this much, and then change in kinetic energy is work done, and you get the value of 50 joules as the answer of work done. Right? Let's go to the next question now. Okay, now let's go to the next question, question number 6. The relation between the displacement x and the time t of a particle under a constant force t is going to be equal to under root x plus 3, where x is in meters and t is in seconds. Determine, number 1, the displacement of the particle at an instant when velocity is going to be equal to 0. So we need to find out displacement at time t is equal to 0. To find displacement when t is equal to 0. That's what the first question is. Second question is, find the work done by the force in 6 seconds. This is the second part. So there are two parts of that. We'll first of all handle the first part of it. First part of it, we'll find it out. Okay. Write the same question once again. T is going to be equal to under root x plus 3. We are supposed to find out the displacement. So displacement should be coming separately. Under root x is going to be equal to t minus 3. So squaring on both sides, it gets x is going to be equal to t minus 3 the whole square. Alright. But it is asked, when determine the displacement when velocity is 0. Sorry, not t, velocity is 0. So where the velocity will come? From this expression, how will get velocity? Try to find out. Velocity is going to be equal to dx by dt. So that means, what does it mean by that? You need to differentiate this one. So differentiating this one means twice. This 2 will come here into t minus 3 into to the power of 1 multiplied by, and again differentiate what is inside. So that will become again 1 itself, because t differentiation of t is dt is 1, so it is the same. So the velocity is going to be equal to twice of t minus 3. That's what the velocity is. Okay. Now what it is asked, when v is equal to 0, what happens? When V equal to 0. So 0 is going to be equal to 2 times of t minus 3. So this is going to become 0 here. T is going to be equal to 3 seconds. So t is equal to 3 seconds is the value when velocity is going to be equal to 0. Right? Now what it is asked, displacement of the particle at the instant velocity is equal to 0. We need to find out the displacement. Displacement is this value. We need to find out this value. So when t is going to be equal to 3 seconds, what is the displacement? Is going to be equal to 3 minus 3 the whole square is going to be equal to 0. Displacement will be 0. That is the first part of the question's answer. You are asked to find out the displacement, so we want the velocity also, because velocity was given here. Velocity is the value of 0, so we got the differentiation done and we got velocity. From the velocity we got time, and from the time we have come back to the displacement and find out what is the displacement, because time t we found out when tv is equal to 0. Right? Now the second part of the question is work done by the force when in 6 seconds. So work done in 6 seconds we need to find out. So how will you find out that? So second part is work done in 6 seconds. Work done is equal to force into the displacement. Displacement is delta x. So we need to find out the delta x first of all. Delta x when is equal to be equal to x is equal to 0 minus x is going to be equal to 6 seconds. 0 seconds to 6 seconds we need to find out. Right? So the value of x is already given there. What is the expression of x here? So x is going to be equal to t minus 3 the whole square was the value of this one. So when x is going to be equal to 0, put here, when t is going to be equal to 6 seconds means, so t is going to be equal to 0 seconds, the first part. So what is x 0? So it is going to be 0, t is 0 here, minus 3 the whole square. So what is x naught? 9 meters you will get, because it is 0 minus 3 square, minus 3 square will be 9. So next is when t is going to be equal to 6 seconds. So what is x6 will be? It will become equal to t you put here 6 minus 3 the whole square. 6 minus 3 is 3 square. So what is that one? It will be also 9 meters. Alright. Now this is 9 meters. So what is delta x is going to be equal to? 9 meters minus 9 meters, because this is also 9 meters, this is also 9 meters. So what is the delta x? 0. The displacement is 0. If the displacement is 0, what is the work done? So the work done is going to be equal to force into delta x. That is also will be equal to 0. So work done is 0. In that particular 0 to 6 seconds, it is work done is going to be equal to 0. So that's the answer. Alright, we'll go to the next question now. Question number 7. A man weighing 70 kg carries a 30 kg box to the top of a building 20 meters high. Calculate the work done by the man. It's a very, very simple, easy question. So mass is going to be equal to 70 plus 30. How much? 100 grams, 100 kgs total. What is the height? He is taking 20 meters. G is already given 9.8. So what is the potential energy? mgh is 100 into 9.8 into 20. You get the answer. What is the total work done? That is the work done which will be there. Please do it. It's quite easy. Go to the next question now. Question number 8. In the next page, a man pulls, I'm just reading here, a man pulls a box on a horizontal floor through a distance of 20 meters. So x is going to be equal to 20 meters. and the force given is 30 newtons along a rope tied in the box in an angle of 60 degrees. Theta is going to be equal to 60 degrees. So here's the box here. So he is applying a force 60 degrees. This is the force which is applied, and 20 meters the box moves, right? And 30 newtons is the value. Now calculate the work done. So work done should be the force along this direction we need to take. What is the force along this direction? Then only that's the way it is displacement is happening. Displacement is happening in this direction, not in the top direction. So what force is going to be applied along the displacement? That is going to be equal to F cos 60. So what is the work done? Is going to be equal to F cos 60 into 20. 20 is the distance. So what is F cos 30? 30 into cos 60 is 1 by 2 into 20. So what is the value here? This is 15. 15 into 20. You get an answer, right? It is going to be 300 joules is going to be the answer. Right, we'll go to the next question now. This is a pretty simple question. A cyclist, after stopping pedaling, comes to stop in 10 meters. 10 meters duration, the cycle finally stops. So distance is going to be equal to 10 meters. Under the frictional force of 200 newtons. 200 newtons is trying to stop this one. What is the work done by the frictional force on the cycle? So work done by the frictional force by frictional force. W is going to be equal to F into S. You can say F dot S, right? So it's going to be equal to 200 into 10, and it's going to be the negative direction. So you get here 2000 joules of work done. What is the work done by the road on the cycle? By the road on the cycle means it is Fs cos 180, because road is doing a work. It is pulling, and cycle is going in this direction, cycle is going, but frictional force is acting in this direction here. So there is 180 degrees will be there. So you get here minus 2000 you will get, right? How much is the work done by the cycle on the road? That will be zero work done. Cycle cannot do any work on the road because cycle will not be able to move the road and all. Cycle is just moving on the road, road is static only. So that work done by the cycle, the cycle on the road. The cycle which is doing a work on the road is zero. Okay, so that's what the second part of the question is. Let us go to the next question now. Yeah, this will be the last question for today. A chain is placed on a frictionless table such that its 1/5 of the part is hanging down. 1/5 is hanging down like this over the edge of the table. If the length of the chain be L and mass be M, the total length is L and then total mass is M, then how much work will be done in pulling up the hanging part of the chain back on the table? You need to pull in this direction. You are pulling it up so that this hanging part also comes up. So what is the value here? This is the hanging part. This hanging part mass we need to find out. Mass of hanging part of chain is going to be equal to M by 5, because 1/5 is only hanging down, right? And length is L, alright. Length of hanging part is already given here as L by 5. Alright, we need to find out the work done. Alright, now once you wanted to find the work done, so the work done is going to be equal to M into G into H. So that's the basic thing. Force into distance, you need to find it out. That will be equal to mass is m by 5. It is going to be g value. And what is the height? Now remember, this is hanging, only this much is hanging. Once you pull it up, your center of gravity has to come up. The remaining part has a center of gravity is this much. This is the center of gravity. Exactly middle of this one. If this much height it is pulled up itself, your center of gravity, if it goes up itself, then work is done. Remember that. This part, the center part of it, of this small segment, when it goes up itself, the work is done. That means the height which is going to be going up is from here to the center part of it. Half of L by 5. So the height is going to be equal to half of L by 5. So why it is half of L by 5? We can write down here separately. Height is going to be equal to half of L by 5. It is center of gravity of the remaining length. So center of gravity is half, it is there, and L by 5. So it's going to be equal to L by 10. That is height. Height is going to be equal to L by 10. So what you have done? M into G into L by 10. That is work done. So it's going to be equal to mgh upon 50. So that is work done. Right? So that will be the work done in bringing this small part of the chain up will be mgh upon 50. That's what the answer is. mgl upon 50, not mgh, mgl. Please write down. Alright children, with this I close. What you will do is, you will be doing some numericals as a homework, which is there given in the exercise question. So turn to page number 383, and you will do the first, from the first question till the 9th question. You will try the first 9 questions. Let's see how it works. Okay, thank you.